Okay. All right. So I'm going to share my screen right now. Okay, for the slides. Okay. So last class we talked about safety, okay, and some statistical information about Malaysian safety, okay, accident caused by protection failure, and then we talk about, okay, like again what is the ultimate objective of protections, okay? So basically is to protect life, protect asset, okay, from overloading, short circuit fault, okay, caused by man-made and nature. Okay, I need to stress again, this slide is very important because it simply answers the question of what is the objective of protections. Okay, so, and then we come down, okay, to various type of fault. Okay, fault referring to short circuit. Okay, now short circuit means that, like in this case, with in a single phase means that you take a live and the neutral line that you short them together. Okay, so that is referring as a fault. Okay, and then in three phase there are four types of different fault. Okay, single line to ground. Okay, like this one. And then we have the double line to ground, not to ground, but double line short together, or double line short together, okay, to the ground, or all three phase that short together. Now in power system, the fault or the short circuit is not necessarily 0 ohm, okay, because for many of our E&E students, because we actually study a lot of DC, okay? So we always assume, oh, short circuit means 0 ohm. Now in power system, short circuit may not be 0 ohm. It can be 1 ohm, it can be 0.5 ohm. So there are some resistance, okay? Now, simply because, they are high voltage, high current system, okay, that produce high power. So this short circuit is not necessarily 0 ohm, okay. And then, okay, basic, okay, generation, okay, transmission and distributions. Now at every stage, okay, of this power delivery from the generator, okay, they actually have some form of protection. Okay, most of the time, of course, when we talk about power system, we always, okay, ignore, okay, or don't talk about the protection here, all right? But it's there, okay? For example, transformer, generator, okay, they have protection, okay, all the boxes. Transmission, they have protection. Transformer, they have protection, okay, and then obviously distribution line, all of them have protection. And then, okay, these are very basic concepts, okay, of protections diagram, okay, where you will have this is the feeder line you're going to protect, okay, and then number 52 CB, circuit breaker, okay, this referring to the switchgear, okay, we are talking about. And then CT, okay, which is the current transformer used to measure the current. And then it connected to what we call a protective relay, or sometimes we call protection relay. Okay, protection relay is a device, okay, that will measure the current and decided, okay, when to trip the circuit breaker. Okay, so setting the relay is also very important. If you set it wrongly, so your when fault happen, it may not trips. Okay, and then we will come to protection zone again. There are various type of protection zone. Okay, so you will see that your protection is not, like infinity. You protect everywhere from here to the generator. So they have a range. Okay, so this range is referring as the protection zone. Okay, and then this is to talk about where to put all the CTs. Okay, this one we will go into detail. Okay, protection basically in two category. Okay, non-unit protection and unit protections. Okay, two types. Now, non-unit protection is the one that we commonly see in our house. Okay, or any like the circuit breaker protect from upstream to the downstream. Okay, and then unit protection means that you protect a particular devices. If we look at the example here, okay, we can see, okay, now in this case, in this transformer, okay, and the front and back they have circuit breaker, right? So this circuit breaker, okay, may connected to one protective relay. Okay, that means it only protect the device in between here. It won't bother about whatever out there. Okay, say there is unit protection. So non-unit protection means that, for example, if I have a protection relay here, I protect whatever downstream, but of course not all the way down. There is a range. Okay, there is a zone. For example, the entire transmission line until this one. Okay, so that is what we call a unit protections. Okay, so up to this point, any questions? Okay, while I'm sharing my screen, right, I can't see your chat box. So when I ask any question, if you have any question, please speak to the mic directly so I can hear you. Okay, so next thing is about primary and backup protections. Okay, protection always have backup. Like I said, because it has a limited zone. Let's say, for example, in our house, if our breaker doesn't trip, so it will go upstream. Okay, it will go upstream. Some of the houses may have the MCCB, so the MCCB will trip. Okay, some of the houses they don't have MCCB, so it will go all the way to the fuse. All right, there is a fuse at our meter there. Okay, so that act as a backup protections. Okay, if our MCCB inside does fail to operate, so they always have primary and the backup protections. Okay. Okay. So we come to, today we will talk about the domestic, and residential protections. All right. So for domestic residential protections, for short circuit and overload protections. Okay. So for houses, domestic, they basically have like fuses. Okay, so the fuse is always at the meter there. Okay, at the meter. And then, like I say, some houses may have MCCB. Okay, more case circuit breaker. And then most of the house, of course, we will have the MCB. Okay, miniature circuit breaker. And then we also have what we call the residue current protections, RCD. Okay, so these are a few terms. Okay, you make sure you have to make it very clear. So RCD, residue current devices. This is the category name. Okay, the category. So it includes the RCCB. Okay, which is the one that are used in our house. residual current circuit breaker. And then we also have this, what we call RCBO. Okay, so RCBO is the combination of residual current circuit breaker plus overload current protection, which means RCBO is the combination of RCCB and MCB together in one devices. So if we look at the Google, so I will show you, how this device look like. Oh, okay. So if you type MCB, okay, this is the common one we see. Okay. Okay, now you can see MCB is already a standard acronym. In Google, you type MCB, okay, this thing will come up. Okay, these are all MCB. Okay, and then MCB, of course, most of the time in our houses, we will use a single phase, so it connect to the live only. Okay, it doesn't connect any neutral. Okay, of course, for three-phase system, it will be something like that. At the same time, it got three pole. And then they also have two pole, where it protect live and neutral. And two pole also have this what we call the DC version, the one that is used for PV system. Now PV usually will have two pole, plus and minus, because DC. Okay, so of course, yeah, different colors is just simply different brand. Okay, simply different brand of this. Now in the class, usually I'll bring a few pieces for you guys to see. Okay, but unfortunately, yeah, we don't have face-to-face this semester. And then MCCB is a big version of what we call this MCB. Okay, just like the big brother, of this MCB. So it's usually bigger in size, and then it is usually three-phase. Okay, there's no single phase. That's why it's usually they put it at the upstream. That's why just now I mentioned some houses have, some houses don't have. Okay, now if your house has a three-phase system, yeah, most likely you will have one disk. But most of our house, it's not three-phase, so we don't have this MCCB, for small houses. And then, yeah, okay, maybe we will just type MCCB. So you will see that, MCCB is pretty big sizes, high ampere, all right. So look something like that. And then most likely it is in the distribution panel, big, large, what we call floor distribution panel. Okay, let's see, apply. Okay, let's see any pictures. Okay, they use in the floor distribution panel, something like, like that. In UCSI building, we see a lot of this, near the lift, right? And we open, of course, they are MCB inside. Most probably they will have a panel to actually, block it for safety purposes, something like that. Okay, you open up, you will see they usually put behind the riser, and then they are all large, switches. So when that means is for the entire floor. Okay, so if you go to block C, at the 4th floor, lift there, you will see there's a lot of panel. So when you turn off one of these, one of the class will be entirely black out. Okay, so it's consider the upstream, okay, distributions. And then okay, this is what we call riser distribution board. Now riser means on multi-level building, like this one, we got first, any big building like that, okay. So it will go all the way up to different floor, right? So you will see there's one pillar, okay, that is called riser, okay. And then this is how it looks like, okay, the riser, where it allows all, the cable tray, everything go all the way up to different floor, something like that. And when it reaches a certain floor, you will see a lot of this panel, okay. You see this panel like bus ducts, okay, all this panel, okay, like this one, okay, to connect to a certain floor. And then let's see. Oh no, this one is the control panel. Okay. Riser distribution panel. Okay, it's already there. Okay, so that is where you see a lot of the MCCB there. Okay. So, and then, okay. And we talk about the RCCB. Okay. So RCCB. RCCB. Okay, RCCB, usually the easiest way to see is that it is always minimum 2 pole. Okay, for 3-phase, it got 4. It include the neutral. It must have a neutral, okay, or else it won't work. All right. So for example, this one, okay, 2 pole. So most of the houses, the only 2 pole plus, there must be a button there. There must be a test button. Okay, you can see there's a test button. All right. So this is how you can recognize the RCCB. So RCCB is not protect the overload and short circuit or fault. It protect leakage current. Okay, it protect the leakage current. All right. And then the test button is very important here. Okay. Now you should press this test button, okay, every 6 months. Okay, to make sure this thing is still working, because this thing is not forever working. There are many accidents actually happen. Okay, people get electrocuted. Okay, simply because this RCCB does not operate. Now, like I said, MCB protect short circuit and overload. So MCB is protecting your asset, your device, okay? And RCCB is protecting your life. It's not protecting your device, it's protecting your life. That's why it always comes with a test button to make sure this thing works. Now, leakage current, okay, happen, it usually flow through your body, right? So this thing will detect. Now imagine if this thing does not work. So it will kill you. So if this thing works, it trips. So it saves your life. So a very important practice for this one is that, like I said, please go and test it every 6 months. Okay. Now, ask yourself, when's the last time you test this? I bet that you will say, I never test before. Am I right? Hello? You guys still there?
Yes.
Yes, sir. Yes, sir.
Okay, like I said, when I share screen, I can't see the chat box. Okay, just give me some response. So it's very important you do that in your house, even if it's rental house. Okay, your family house more important. Now this thing, like I said, why it's so important? There are many accidents happen because of this does not operate. Okay, okay. Let's say I'll show you example. Okay. Now, if you talk water heater accident in Malaysia, you will actually find that there are lots of these, news. Okay. Now, this is not to scare you guys. Okay, this is to let you know why it does happen as an E&E engineer. Okay, just to make sure that you all take note of this issue. Okay, so electrocuted. Okay, the shower. You see, a lot of people always blame the water heater. Okay, when this type of what we call this accident happen. Okay, now in fact, the real culprit is not the water heater, is your house RCCB. Okay, now there are many cases. Okay, student okay, Malaysian student electrocuted by water heater having shower. Okay, wow, is everything so slow? So you see, this is simply caused by leakage current, not by the water heater. Okay, it is by leakage current anywhere in your house. Water heater is just only a medium, okay, to conduct current. Okay, so people will actually, get electrocuted, okay, during shower. So like I said, oh, my internet very, very slow. Okay, I mean, you can just type like, there are many, every year we have all these news, okay, happening. Okay, now most of the time after investigation, they actually found that, okay, it's not a water heater. Okay, now if you want to see, maybe I can show you, I'm using a whiteboard to show, do more, a little bit more explanation. Okay. 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 All right. Now, and this whiteboard here, okay. You guys can see, right, the whiteboard right now?
Can, sir.
Okay.
Yes.
See.
Okay.
Yes,
Now,
sir.
we have these, okay, let's say we have this RCCB. We have a circuit go through, okay, okay, a load. Okay, maybe I just, yeah, it erases everything. Okay, never mind. Now the principle of this RCCB is we have a source. Now the current go in, let's say is 1 amp. Okay, through the load and come back. Must be 1 amp as well, right? The live and neutral. That's mean when you measure here, current 1 amp, you hear also 1 amp. That's mean good, no leakage current. So your if you have a RCCB here, the resultant current is 0 amp. Simply because this is plus 1 amp. When it come back, it's minus 1 amp. Okay, so no problem. Now, this can be anything. Let's say this can be even your home Wi-Fi system, your TV or whatever can cause you leakage current. Our computer also have leakage current. Everything has. Now, let's say if I have 1 amp in, because there are leakage current here. Now, leakage current usually are very small. Okay, let's say 0.1 amp only. Okay, it leak out, which is connected to maybe earth or whatever, anything. Then your returning current will be 0.9. So the resultant is no longer 0. Okay, so your resultant will be 0.1 difference, which is tell you that, hey, you got leakage current somewhere in your house. If this RCCB is in good condition, okay, then it trips. Now imagine, like I said, the water shower thing. Okay, water shower system. Okay. You see, our house water pipe is connected to earth, most of the time if the earth is connected properly okay, and then it is interconnect. Now every house we have all these earth connection, but for some reason sometimes if this earth is not connected properly, okay, then this leakage current will go through, all our house pipe will be connected to the earth. Then this leakage current will go through, and then of course metal, right? All the pipe will go through the water heater shower. Even your shower do not have water heater. If the earth is not, then if you are here taking shower, you get electrocuted for this reason. Okay, so like I said, this actually play a very important role. Okay, even your earth or whatever is not properly, but as long as there are leakage, the return is not equals to the one that is coming, then your RCB will trip. When it trip, of course, the power supply to this one to the load will be disconnected. When it disconnected means that there will be no leakage current. No leakage current means that it saves you. Okay, so like I said, it's very important, okay, to understand. Of course, sometimes water heater do have problem, but it's not always the water heater. And majority of this accident is simply the RCCB does not work, okay, or the connection of the the earth are not proper. That's why investigation have to take place. Now
Hello, sir.
Yes.
So the RCCB acts as the earth, is it?
No, it doesn't act as earth. It acts as, you see, it just take live and neutral. It does not connect to the earth.
Okay.
It just make sure that there's no leakage current.
Okay.
You see, imagine leakage current. Another very dangerous leakage current is your electric water, your kettles. Okay, you boil water, those, okay, like that. Now, if there are leakage current, that means the whole this part, is what we call this, will have this current, let's say 0.1. And your hand and go and touch it, you get electrocuted.
Yeah.
Then if your RCCB is working fine. When this thing got problem, it trips.
Okay.
It trips. Now the problem is that most of these things sit in your house. Okay, the age of this RCCB is almost the same age of your house. Right? Now, how many of you stay in Angkasa? Now, Angkasa has been there for, I think, around 15 to 16 years already, you know. So if the moment you move in a new house, the first thing you do is to test this. And remember, put a sticky note there, write down the date of your test. Then every time you look at it, you know, oh, it has been half year, I never test. Because this is just a very simple mechanical stuff, you know, just like your car, you need service. Okay, thing may broke down, you may not work anymore, you don't know. Okay, so it is very, very important, you know, for you guys to actually do this at home. Okay, so that you make sure it's not only protecting you, you know, protecting your family, your housemate. You know, maybe you are the only one who study E&E, the rest are not. So, you know, knowledge is not just for you to score A in your exam, you know, it is help you to protect life. Okay, so very important of this. Okay, so this give you some examples. So as I move on, then we'll talk more about it. Okay. Okay. All right, now come back to the slide here. Okay, so this is some basic example. And then, okay, now we come to fuses. You will see all these in your houses. Okay, these are the single phase one. Okay, now single phase, you will notice. Okay, how come single phase 4 wire? Okay, it is just because of 2 wire in, 2 wire out. Live, neutral, live, neutral. Okay, so it looks like, wow, 4. So this is single phase. And you will usually see, okay, these are fuses. If everything does not trip inside, then the fuse will, you know, fuse mean blow lah, you know, you cannot reset it. So then you have to call the TMB to come. So in a way, it is good. Okay, the TMB will come. Okay, and then they will, you know, do investigation and what we call this, replace the fuse for you. Okay. 1 time 10 in 16 years. Yes, you have to go and test, you know, every 6 months. That is already considered, you know, very, very long time already. Okay, and these are the 3 phases. Now you see 3 phases, you got 3 fuse. 1 fuse for 1 phase, and you look at the meter, there are how many wires? 2, it's all 8 wires, double. Okay, double of this. Okay, and this is the neutral. Okay, neutral connection. Okay, so yeah, this is how the fuse look like. Okay, you can take it off and put it back. Okay. Okay. When you go inside your house, okay, this is what you see. Okay. Now, do you notice that there is one RCCB there? The rest is MCB. Okay, the rest is MCB. Okay, so different house, different design. Okay, but those who are doing my design project, I'm not sure any of you doing my design project last semester. Any one of you? Hello?
Yes, sir. Yes, sir. Yes, sir.
So you guys are actually, yeah, I'm asking you guys to do this, right? So, you know,
Yep.
you will have this RCB, MCB. So you actually experience yourself by building a small demo version of this, yeah, electrical households. Okay. Yeah, but this semester I cannot do that because of MCO. So maybe next year we're going to do something like that again, or a real power system. Okay. Okay, again, some pictures of MCB and MCCB. Now, another thing you will notice that for MCCB, some of them can be, adjust. You see, there are something, there are screw that you can adjust, set the M. Okay, so some of them does not have. Of course, most of these in-house one cannot set fixed. Okay, they are all fixed. And then this RCD, like I say, RCD is a device that comprises of RCCB, okay, and this RCBO. Now you will see, how come RCCB only got like something like one line? In fact, it also have live and neutral. Okay, usually they will have one wire coming out for you to connect. Like I say, it need a neutral line to work. Okay, so this is simply because a design, okay, that combine both together, okay, to save, okay, space, okay, or most of the time, this thing, okay, are put in the public area. Okay, public area as in, let's see if I can find something. Public area, okay, call, is it column? Pillar, I think we call pillar socket. Okay, outdoor pillar socket. Okay, okay, indoor. Pillar. Oh, this is filler. Okay, should be building. Okay, something like, something like that. Okay, this is outdoor. Indoor, we do have, okay, like you will see most of the time this indoor pillar or building, sometimes they call column, power socket, okay, at the column, even at UCSI or Starbucks, for example, you will see this or shopping complex, there are pillar, okay, and then at the bottom of the pillar, they actually have this power socket. And where this power socket, okay, a pillar is something like that, especially big building, right? And then you will see a power socket sometime here, okay? So it's basically for the use of the cleaner, to put the vacuum machine or whatever. But sometimes I do see shoppers go in there and charge their headphone, okay? So nothing wrong. But usually for those public can easily access one, you will put this in, 2-in-1. Okay, you protect live, leakage current, you protect overload, short circuit from any device that's connected to it. Okay, so obviously it will be much more expensive because you're buying two devices at the same time. Advantage is that, okay, sometimes like for example, you already run out of space. Okay, maybe you only have one slot lah. Okay, and then you need another, RCCB or whatever special outlet you need to protect. Then you will need to consider using this one. Then of course nowadays they also have something like that already. The power socket already got built-in RCD inside. Okay, so it's even more safe space. All right, you have a test button and a reset button. Okay, so when you trip, you reset them. But this one is not 2-in-1. This one is only RCCB, but built in, okay, into a power socket outlet. So now we move on, okay, to MCB. Now what this MCB does is, like I said, a protect overload. Now imagine, okay, one MCB is connected to many sockets, okay, and then let's say in this case it's 30 amp, right? 10, 30 amp, okay. And what happened is that in protection, cable is very important. Okay, cable is very important. Like, okay, there are three numbers you basically need to know. Okay, one is 2.5 mm square. 2.5 mm square is a standard, okay, cable that is used in our house power socket. 2.5. And then 1.5 mm is used for your house or any building lighting system. Your light is 1.5. Okay. Then another one is 4 mm square. Okay. Now, take this example. Why cable is important? Because, like in this case, 2.5 mm square can take up to 24 amps. Now, if let's say you connect everything together and more than 24 amp in this case, what happened? Your cable cannot withstand. So when your cable cannot withstand, it will heat up. Okay, when it heat up, the insulator out there will start to melt. So when the insulator start to melt, okay, then it will start to cause short circuit to the neutral. This is how fault happens. It does not happen immediately. It takes some time. Maybe today you try, wow, no problem. Say, sir, you know, you see, I try, nothing happened. Of course, it does not melt immediately. It's only 30 amp. Of course, you put another 140 amp, then it melt faster. Okay.
Hello, sir.
Yes.
Sir, so let's say for water heater, all like what sizing we should use? Is it 2.5 mm square
No,
or
for water heater, it's 4 mm square.
4 mm square?
Okay.
Okay.
2.5 also can, but it depends on your water heater power also, right?
Okay.
If you buy a big one, that storage one, you know, I will talk about that later, okay?
Okay, sir.
So just for a standard of any power socket used in our house, not industry, domestic offices, even use ASI office, is 2.5 mm square. Now, I find that for students, it's very difficult for them to comprehend this, simply because since year one, you guys study electronic, you guys do breadboard, right? All small little cable. So but now you are electrical engineer. So make sure that you have some sense of this cable. Like I say again, I can't show you the real cable because you know normally in the face-to-face class I will bring this cable, okay, to the class so let you guys see because it's important for you to see and feel. All right, because many of engineer when they first graduate, like I said, you want to be electrical engineer, right? Go to consultancy, go to contractor. And usually the very first job they ask you to do, right? Okay, go to the site and do inspection. That's the basic job. Inspection means that because those workers are foreign workers that will do the installation, you know, the hard job lah. Okay, but they are not trained engineer. Okay, and you need to go there to make sure they are doing the wiring correctly, they're using the correct cable. Because to them, sometimes they cannot distinguish, you know, the different size of cable. Cable is cable lah, right? For you guys, as long as conduct power. Then you have to go and see, you know, you touch and see, you can see, oh, this is 2.5. No, this is 1.5. You are doing the wrong one. Ask them to rewire it again. So it may look very boring and simple, but it is a very important skill for you to go. It's just like doctor lah, you know, when they start doing clinical patient, they need more time to actually diagnose your problem. When they have many years experience, the moment you tell them the symptom, they can immediately know, oh, this is what problem. They will prescribe the medicine for you immediately. Same for engineers. So, you know, I know that some of the students, when they're doing co-op, they already do this. But sometimes the student does not appreciate this type of opportunity. It's not everyone have the opportunity to see this. Why? For example, all the cable inside the wall already. How are you going to see inside? You only can see when they are start doing it, right? And you can see how they put inside the conduit. When the building finish, everything is inside. So it's very important. You know, it's just like components, electronic component. When you see, you know, this is a capacitor, this is inductor, this is what, this is what. Okay, so come back to here. Okay, now this MCB, like I said, it will protect overload for you. So when it's overload, it won't trip immediately. It depends on how much overload you have. Okay, so obviously if this thing is work, okay, when you have this type of overload, it will trip. Okay, so too many appliances on the socket outlet. This is commonly happen to us. Why? Because many of the building, okay, like old building lah, I'm referring, Angkasa was built in, I think it's 2004, 2005. 15 years, right? Back then got iPhone ah? No, iPhone is 2007. No iPad, right? So a lot of electrical appliances are still like, you know, not many, not common. Okay, we don't have this fast charging thing, you know. Every phone now we bring back the charge is 8 hours, right? So it's slow charge, slow current. And then they usually only have one socket in one room. And when the student move in, they buy extension, right? Extension plus extension, plug everything inside. Then, you know, and of course, there are chances there will be overload. And also, there are also cases, okay, like, because now you cannot see what is inside your wall, okay. Now, what if lah? Just say what if there are actually many cases that, you know, sometimes they install the wrong cable, like 2 mm and 2.5, you know, are very close. You may not know, you know, if you are not experienced enough to actually see it, okay. And then if there are cable that is what we call not sized correctly, and then obviously when this type of overload happen, okay, it will melt faster. All right. And then overload, okay, it can be also called electrical motor become jam. Okay, so these are overload. All right. And then short circuit, like I say, fault. Okay, fault, of course, most of the time it is caused by long-term overload. Okay, so the insulator start to melt off slowly. Secondly is renovation. You know, sometimes we want to renovate our house, we drill holes and accidentally you drill through the cable. Okay, or you not drill through the cable, you damage the insulator without knowing it. There is a cable inside the wall. So it's important sometimes for the installer to buy a cable detector to detect whether is that a cable inside the wall or not, so you don't drill that portion. Okay, so you know, mechanical damage, insulator breakdown. This is just insulator, you know, it can last long as you don't overload it, okay, to cause meltdown. And very low chance that it's caused by like insect, and you know, sometimes mouse or whatever, rats, you know, can just bite off the insulator. Okay, we don't know. All right, but most of the time, if this is inside the wall, of course, on the outside is usually your device that causing a short circuit. Okay, and then the MCB, okay, the MCB have thermal and magnetic circuit. It's a thermal magnetic circuit breaker. Remember, it protects two things. Our circuit breaker protect overload plus short circuit. And how this thing works, okay? So let's see. Okay, again, same photo. Now, when you open the inside, you will see that there is a magnetic coil here. Okay, see, the go in, go through the magnetic coil, and then go through the connection. Okay, and come back here. Now, the magnetic coil here is to protect short circuit. So when you have short circuit, the current will be very, very high, 16 amp, for example, 60 amp. So it will create a very strong magnet, okay, to trip this relay, and then this thing, okay, will trip down. That is to protect, okay, the what we call this the short circuit. Whereas at this portion here, there is a bimetal plate. Bimetal plate means the metal will start to bend, okay, when it is heat up. Okay, that is to protect overload. Okay, that is to protect overload. If there's no overload, it won't bend, right? So if it's overload, it will start to bend slowly, depend on how much overload. You have a very high overload, or it bend faster. Okay, so it bend, it also can trip. Okay, this one. And you will notice that there is a series of this, what we call arc tube. Okay, okay, this is the arc chamber. So when it trip, right? Okay, so there's usually arcs in between. So the arc, okay, just like lightning, the arc, okay, even though your circuit is already open, but the arc is still there, it still continuously conduct current, right? So you have to think of how to quickly, okay, distinguish the arc. So this is the arc tube. Later I will show you a videos in YouTube, okay, for the arc tube. And you notice these two pieces. Okay, this is a good version. This is a counterfeit version. There are many counterfeit circuit breaker out there in the market. First rules, get the branded one. Okay, Hager, ABB, Schneider, top brand. Okay, Max, all these are Malaysia local, good brand. Okay, now there are many. If you go to many of these Jalan Pasar hardware shop, they also selling circuit breaker at very low cost, super low cost. And when you open it inside, you will see the coin is only 3 rounds because they want to save money for the copper. So that means the short circuit, I'm not sure can trust or not. Will the magnetic field strong enough to trip? Okay, so that means if it put 6 amp, maybe you need 10 amp to trap. So there will be a problem. And the arc shoot, you see the arc shoot, the metal plate here. You see in between there are empty one, and you see this, every one of them are actually full with metal plate. Okay, so how to distinguish counterfeit? Of course, you cannot open. Very simple. You take an original branded one, Schneider, for example. You buy another Schneider counterfeit. On the outside, they look exactly the same. How to distinguish is you hold it on your whole hand, 2 hands, you feel the weight. The one heavier one will be the original one because they have all this material much more better inside. Okay, the circuit breaker. Okay, all right. Maybe let's try to find the YouTube. Okay, to show you guys. Okay, now I try to include the audio. Okay, and I think today no need MATLAB already like that. Okay. Oh. Okay. MCB. Okay. Okay, arc shoot, parachute, what is parachute? Okay, there's arc shoot. Okay, this is miniatures. Okay, ABB, they have the very good videos where I think this should be a good one. Okay. You guys can hear the sound, right? Hello?
Yes.
Okay.
Yes, sir. Yes.
Can, sir.
ABB's miniature circuit breakers offer a compact solution to meet today's increasing energy and protection requirements. ABB's miniature circuit breakers are current limiting, making them more than twice as fast as standard zero-crossing circuit breakers, thereby significantly reducing the let-through energy, risk of arc flash, and damage to connected components. This allows response time and tripping characteristics equivalent to fused systems. The following is actual high-speed footage of an ABB miniature circuit breaker clearing a downstream fault. In real time, this entire event takes place in less than 3 milliseconds. Within a half millisecond after the short circuit current is released, the coil registers the increased current due to the fault. The hammer trip forces the contacts to open, while current continues to flow through the arc, which...
Okay, like I said, you see, when short circuit happen, right, because they are very, very high current, and then even you see, it's already open, the circuit already open, but you know, the arc is still there. So when the circuit is already open and the arc is still there, means that, you know, the current still flow through, okay?
still exists between the fixed and movable contacts. The unequal pressure across the arc causes the plasma wave to be driven away from the contacts into the arc extinguishing chamber.
Okay, you see, these are the arc extinguishing chamber. Okay, these are all the plasma. Okay, so you see how the metal plate here actually neutralizing or distinguishing, okay, the plasma and the arc.
As the arc enters the 12 evenly spaced arc chute dividers, it is broken up into smaller 30-volt arcs that are individually extinguished. The arc tries to restrike, but the plasma is again driven into the chute and extinguished. In less than 3 milliseconds after the short circuit current is released, the fault is safely cleared.
So it took like around 3 milliseconds. Okay, now you can see the arc will try to, try to re-energize again in between. Okay, so you see just now I show you the counterfeit one. They just have, I'm not sure, like this one is 12 pieces. They only put like 6 pieces half. So it may take longer time than 3 milliseconds for the arc to completely distinguish.
ABB miniature circuit breakers utilize current limiting technology to reduce hazardous let-through energy and extinguish the fault in a timely fashion. In applications where downtime can be costly, be sure to use ABB miniature circuit breakers to ensure uptime all the time.
Okay, so yeah, hope this will give you guys a better idea, okay, about this arc chute, okay, why it has to be there. Okay, like you see this one, very clear cut, because it's really metal, copper is expensive, metal is expensive, so if you use less, cheaper, okay, then cheaper is usually lighter, okay, and those heavy one, okay, the arc chute is much more better. Okay, so yeah, don't save this type of money, because this thing can last for years, and you save it for money, then that you put your asset, okay, into the risk. Something, I think, protection, there is no way to actually try to reduce the cost, because you reduce the cost, you reduce your own safety, as simple as that. Okay, so yeah, be ethical engineers. Okay, safety is the utmost, okay, important, okay, in any of our electric circuit design. All right, try not to say, okay lah, this part no need lah, no people are going to touch it, you don't need to put protection. Don't ever think about that, because even like something like a water pump, all these things, normal people may not go and touch it, okay, but there is always maintenance, right? And the maintenance guy need to clean the pump, everything, they need to go there. And if you don't put a breaker there, protection, you just put the guy into danger, who's going to do the service. Okay, of course they don't know whether you, of course, you know, you are doing the putting the protection, you know, for the thing or not. Okay, so this is something that we should not overlook. Okay, as the electrical engineers. Okay, now we look at the symbols. Okay, there are two common symbols used nowadays. If we are following the IEC standard, okay, these are the symbols. Okay, so the symbols you will see, it will have like one of these come down and switch. Okay, so these semicircles here or a dome side, it represents magnetic. Okay, so to trip for the for current, and the square one here represent the thermal trip, the bimetal strip for overload, and of course these are the switch breaker, the making and breaking. Okay, making is connect, breaking is open. Okay, so this is the symbol. So it is depends on yeah, your projects. Okay, let's say if you are doing a project in Europe, okay, you are a consultancy, let's say you have a project from Europe to do this simple design. Okay, then you have to make sure that, you know, in Europe they all follow IEC standard. Okay, Malaysia do follow as well. Okay, but it depends. Okay, because Malaysia we heavily practice two different symbols. Okay, then you make sure you have to draw this. Only the engineer there can understand. Now in Malaysia, we use this. Okay, let me just go faster. PC. Oh, that's all IEC standard lah. Wow. Oh, okay. In Malaysia, we use this. Okay, we call happy face. 2 dot and 1 like, you know, inverted happy face. Okay, if you turn it around, it's just like happy face. Okay, because it depends on how you draw a diagram. So this is what Malaysia consultant and what we call this contractor. When you draw this, the contractor can understand, oh, these are all MCB. Okay, so you have to really go back to your country for those international students to understand your country. Okay, you know, are following what types of standards. Okay, the drawing symbols are in other words. Okay, so for this type of electrical protections for the domestic, okay, we need to know MCB and MCCB. Okay, and then okay, tripping characteristic. Now you can see, okay, there are different curve, tripping curve, okay, for MCB. There are B, C, and D. Okay, so the one that used at our house is is C, sorry. Okay, is C. Okay, so like for example, how to see? Okay, for example, in this case, this is type C. Okay, type C and 10M. Okay, type C and 10M. 10,000 short circuit. Okay, 10,000 M short circuit. All right, and then 230 watt and so forth. Now, what are the difference of this curve? Curve C, 3 to 5, means that if take this case as 10M, okay, so the short circuit will start 5 times, okay, the rated current. Okay, 5 times, that means 50 amps, 50. It trip immediately. Okay, so the short circuit or the fault, anything below 5, okay, is considered, okay, 1 means 1 times how many times? See the X, 10 amps, okay, if 1X means 10 amp, okay, so anything below 10 amp is okay, okay, it won't trip. Anything more than 10 amp, it is considered overload. Anything more than 5 times to 10 times is considered short circuit. So these are the difference curve. Okay, in normal houses, residential, apartment, condo, we use C. Okay, so you have control. Upstream, you can put D. Okay, and downstream, you can put B. Okay, that's why we still can add breaker in our house. Okay, anything from our power socket, if you want to add breaker, you have to add B. You cannot add D. Anything that is upstream, outside the box, onward, you can add a D curve. Okay, so when we see this, okay, curve, this is B, this is C, and this is D. Now we look carefully for C curve. You see this 0, 2, 3, 4, 5, right? 5 to 10 times of the rated. Okay, now let's say 10 M again. You need to reach 15 M, only it trip 0.01 second. This is a tripping time. If it's, let's say, 2 seconds, no, 2 times, definitely 20 M, right? You see 20 M, it does not trip immediately. If you look at the line here, it go all the way up and then come here. Okay, it trip at maybe less than 1 second. Okay, so this curve will tell you how fast it trip. Okay, let's say if it's around 1 time, 10 M, you see, it don't trip immediately. It may take, like, for example, how many minutes, you see, and this is second to trip. That means if you keep it on overload for long enough time, before your cable really melt off, it will trip. So that is overload. Okay, so all this graph, the main difference is basically this. See, B, 3 times only, it already trip immediately, this vertical line here. Okay, this is 5 to 10 times, and D is 10 to 20 times. Okay, so basically these are the tripping curve. This is very, very important. Okay, you have to understand that. Okay, the tripping curve. Okay, so you can install the correct breaker. Okay, so okay, I think it's almost time already, 10 minutes to go. So I think I will stop here for today, and I'm going to take another round of attendance. In the meantime, any questions?
No, sir. No, sir.
Good. Okay. All clear. All right. So yeah, we will focus just for the MCB for a bit of time because it's very important. Okay, in protections. Okay. Now I'm going to call again the name. Okay. For this attendant. Okay. Make sure you guys, yeah, you can get barred. I tell you, no joke. We have to update this thing, in a daily basis. Okay, Rose, are you here?
Yes, sir.
Okay, finally you're here. And then Len Hansen. Len Hansen, are you here? Okay, you're here. Thank you. Lim Hong Xiang. Lim Hong Xiang. Wow. Xiang. You are here. Pang Ka Ho. Pang Ka Ho. Pang Ka Ho, okay. And then Ashka Chang Huri. Akash, sorry. Akash, are you there? Akash, okay, thank you. Neon Jinwei. Neon Jinwei, are you there? Okay, thank you. Wow, full attended. I see a question here. Oh, Jiasun. Oh, question. Oh, 10 times, remember, short circuit 5 to 10 times. so that the short circuit is the maximum 10,000 ma. So that means if you have short circuit more than 10,000 your breaker, your MCB will damage. You see, for C curve, minimum, for the short circuit is 5 times to 10 times. And that MCB is 10 M. Okay? So it is the maximum. You see, what happened is that if you have like 10K or 1K, okay, of this short circuit, okay, it will, what we call, it will weld the connection, you know, it become like welding, you know, it will glue together. So your MCB will never trip. Okay, so that is the maximum it can withstand. Okay.
Okay. And so then got in the graph got one small square 5 to 10 means the
range.
circuit breaker will start to trip in that range.
Yes, you see, because these are mechanical, you know, it is not like electronic. I set 5M, it will trip 5M exactly, right? But the bimetal or the coin magnetic thing, they are what we call this mechanical. It cannot be very precise, so there will be a range, 5 to 10. Now you buy two identical breaker from the same company. One may trip exactly 5.2. Another may trip maybe 5.6, something like that, within the range. But when we design, right, we will usually take the average in between 7.5. Okay, in between. So they will give you a safe, but usually short circuit already 5 times I mean, you know, it's usually very, very high current. So it doesn't really matter.
Okay, so then got one more, the last question, is the magnetic coil and the bimetal plate, they are two different type of tripping.
Yeah, two different type of what we call protection.
Means one is for the temperature, one is for the very high current.
Yes, one is short circuit another the coin is short circuit. You short circuit, okay, then in our house, right, it will draw like 60 M. Then the magnetic will activate just like relay it will trip the thing. And then what if I just overload okay, I just put like the 1.5 times of 10 M is 15 M for in this case. Then the bimetal plate will start to heat up right?
Yeah.
Then it will start to bend it bends slowly until it touches the tripping point, then it trip.
Okay.
You see, when it bend, right, it's just like causing a short circuit okay. It touches, then the magnetic, what we call the magnetic will activate.
Okay, thank you.
So how fast it bend depend on, like in this C type, in between 1 time to 5 times. 1 time it bend very slow. It take maybe 1 or 2 minutes to break. And let's say you put 4 times, maybe a few seconds only it already breaks.
Okay.
The purpose of doing this is to avoid inrush current. You see, when your house got aircon, you turn aircon, the current shoot up very high one, Okay, it's actually very high. So, but it's only for a very short time, just a few seconds, it will come down to normal. Or any motor, water pump, So if we don't have this type of curve, every time you turn on the aircon, it trip. Okay, you turn on everything, it trip. Then your house keep on tripping from day in, day out. Cannot, right? So that's why they design this for a purpose.
So then got one more question is how the arc extinguish chamber
okay, like the video I showed just now. Okay, so when the two maybe I will try to draw okay. Okay, I have to open up the whiteboard again. Okay. Wow, my diagram is still there. Okay. I had to rub all that. Okay, now imagine this is just a simple switches, okay, inside a breaker chamber, okay, and then the chamber got bar, right? All this bar. Okay, now let me just say there is no bar lah. Okay, so what happened when I first open? You will see there will be a arc like that, right?
Yes.
Okay, and the arc will keep on going out because it's a gas. It will go like that slowly. So now if there is no arc shoot, it will just grow like that. And then you keep on and all these things will like that. It take long time until maybe it hit the maximum, nothing else it can do already. It was still there until it is distinguished, just like gas. So it will start to like, okay, distinguish. Okay. So it take but when there is an arc shoot here, and there are metal bar, you see, right? There are metal bar. You see, this metal bar actually blocks the arc. Okay. So when the arc start like that, it glows, and it come here. Got 10 blocks already. It will still go through, okay, but it will weaken already here. And then it come here. Wow, more layer block. Okay, more layer block. It will try to go through. Then of course, what happened is that this one start to disappear. Okay, and then lastly, when this disappear, whatever happened in between here, the arc will start to survive. Say, hey, cannot, I don't want to go. It will start to, it just like gas. It will flow up. But because of all this metal bar as a arc shoot, it will become lesser and lesser until at the end, no more. But you see, when the arc try to go in and out here is already open circuit. Right? So you look back again the ABB video I show you guys in YouTube, you will see when the arc go out, there are some lightning there, right? Just like lightning effect.
Yes.
Yeah. So this arc shoot, this is how it actually extinguish it.
Oh, okay.
Now, like I said, chip breaker, they put less of this bar, right? Maybe they say, okay, I want to save money. I put 4 only. Can also lah, but it take longer time lah. So this is a very interesting phenomenon we can never see unless you are working in the circuit breaker manufacturer. You can see when they test this. Yeah.
Thank you.
All right. Yeah. All right. For those who you want to leave for next class, please go ahead. No problem. I'm here just for any question and discussion here. Yeah. Oh yes, bimetal switch. Yeah, composed of 2 different metal, brass and copper, if I'm not mistaken. Just like the smoke alarm. Yes. Yeah. Okay. 嘉顺啊。你有在啊？
有。
我今天会 email 一个MATLAB file 给你。OK， 我已经写了一个 MPPT BNO 给你。OK，
好，谢谢。
然后OK， 我只是放一个 sample switch 罢了，我没有做 converter OK， 然后你自己去玩一下 understand 怎样 code 它，然后你把它再变成那个 buck converter， 因为那个我没有做，你要自己去算了那边 OK。
可以。
So 给你一个 kickstart。
好。我这里手力我读很慢那个。
不用紧，你读慢不用紧的，最重要是你一定要边读边做，你不可以说等我读完了才做，这样你会更慢。你要边读边做，所以我就做了一个那个给你去 kickstart 一下先。
要读一点做一点，读一点做一点。
对，比如说你要看哪一个，我叫你先做 BNO 那些嘛，然后你要一边 experience，然后一边做这样子。 啊，
哦，
然后 Doctor Lim 那个 part 啊，你就可能需要多一点时间读，或者我们早一天跟他来视讯的时候就可以更好的什么咯。
我在看这最后第二章了，那个 BSO 的，
good，
就差不多要看完了，然后我本来是想看完才做，可是如果你讲一边做一边看，我就可能先做。
对，应该要这样子的啊，应该是要这样子。
我读那个字很慢，我看一句就看1分钟了。
啊，对，不要讲你，我也是读很慢，因为 paper 呢是不容易读的，因为每个作者的写法不一样嘛，所以其实 after 你读完的那些字呢，你要自己去找你的字，就是说是适合自己读的字啊。
我再去找其他 paper 来读了。
对
OK
那个时候到时我再会跟你讲。
好，等我那个
可以
做出来，这几天我会做出来，弄出来我再跟你讲。
可以
OK，谢谢哥哥。
OK。红香你在吗？红香？
就是我在。
现在怎么办 ？OK， 五金店已经开了啊，我已经看到一些五金店已经开了。All right， 有什么东西还要需要五金店的？因为现在
那个房子，
那个你的 casing 现在那是你要赚那个都没有赚到嘛，对不对？
也赚不到，我也是在你那边。
我知道，那赛咯都是你吃咯。那你现在是要这样子，砖头呢，可能你真的要去买了啦，才1-2块钱，便宜的。OK，然后你有朋友有电钻嘛？
这个就是我在一并接着找着
然后这个就是因为我觉得只是差那个罢了嘛，东西全部在你家，你那边你应该可以做那个 box 出来呀嘛，对不对？可以吗？cable 你买了是那个 sensor 的盒子啊
？sensor 盒子没有在你那边呢？
全部还在我那边啊，加辣
那
这样我们要等 MCO 过了才可以啊。而且
我现在只是在
MCO 你能不能回去学校都是个问题。现在 OK，
如果
我要问清楚
真的，如果假设真的我到最后都不能去学校的话，我要讲 proof 跟 defend 我的 title， 因为我那时候昨天那个FYP briefing 的时候，他们讲如果你的那个你要是 hardware part 到最后做不成的话，你要变成 simulation 来 defend 你 title 什么之类的。
不能啊 ，simulation 很 weak 哦，你不能拿，你会 end up 拿到很低分，不可以。我看呢，我会这样子做，我会跟你申请给你进 campus 哦，因为我现在要回 office， 我都要拿信，你知道吗 ？OK， 你住在那附近应该不是问题的第一点是这个，因为他们也不允许我们跟学生，假如说一天见2-3个学生，3个 group 也是太多了，所以我要安排。所以你要好好珍惜。然后 lab 呢，我还尽量跟你问，因为 lab 你都讲 briefing 了嘛，他们都在 control 了的嘛，所以我是看能不能帮你问到这个东西所以that's why你现在在 programming 那边你能够做，你快点做了，你不要到时候再看我回去再 program 多2天再来就是真的是不顶了，不能再浪费时间了。就是说我上次叫你做的那些东西，你要就快做好。OK，then 当然，现在你就做 simulation 哦。你还记得我不是有说你那些 simulation 的那个东西啊？
有。那我看到你 upload 去你的 MATLAB 那边哦。
对，你 upload 了，你把那些 experiment data， 你就用这种 experiment data 的方法来做。OK， 你先自己做先给我看。OK， 到时候会再教你这样做。你一定要有 simulation， 因为没有 data 真的是不行哦。我真的
明白
哇，而且老实讲这个。我觉得应该 OK， 因为6月头它开了，虽然有 distancing， 但是应该不会承包。我很担心是6、7月尾这2段时间，你一定要拿到 data， 最少有1天完整的啦。我觉得 worst case 你要有半夜12点到第2天就是没有断过的，每1分钟没说要很漂亮的。当然我看它可以乱9是最好咯。然后你还有什么 hardware？你还需要买的，还是已经齐了 ？OK， 这个我让你去想，因为我也不懂，我拜五会回去 office， 我会再看一下。 then
可以。
然后OK 就这样子，因为我们也不能做太多东西在那边，所以你好好的坐下来想 ，OK 你还有什么东西需要买的，然后你 methodology 的那个 chapter 就是一开始就讲 simulation 先咯，像 Mr. J 讲，你能 simulate 到什么你就 simulate。OK， 你要做一个可能一个 draft chapter 3给我 ，OK，then chapter 4就是靠你那个 result 了 ，OK， 靠那个呀，就是要这样子，是可以做到的，只要你不要像上次，你就是上一个 semester 很摸，一不见就不见一个礼拜，然后你就很爽，然后找那种4、5点才来 ，lab technician 收工了，你看我还记得的最后一天，你就是插钻那个洞罢了。然后 lab technician 不在，你看你一个 mistake 搞到你现在什么都不能做。OK， 不要再 repeat 这个问题了。
OK，sorry，明白。OK，我去看一下有什么好问题。
你
来，
那个我想问你那个 FYP acceptance form
会是 online 的。OK， 我现在等做
是 online
我等做 day 给我这个 link， 他讲他要用 online 了，因为也是很麻烦，每个人闪。OK。So 会是 online 的，我会到时会通知你们。
就不用 email 给你啦。
对，不用。
好，
现在要东西都很多 online， 我都很乱
好，还有一个什么 risk assessment form
对，那个全部 no 就对了。
那个也是 no， 然后等也是 online 才给你
对，那个我要看先，我不敢动，我懂，应该也是 online 的，我记得
好，这样我过后再问看你咯，如果真的要交的话。
对，可以。
好，谢谢Dr. Ronnie。
可以。Jordan, are you there?
Yes.
你有收到我 email
有收到。
看得懂吗？
那个 paper 我还读着，就 try to 明白那个 simulation 我有开始跟着你的那个做了。
OK， 那你的 project 就是要有 model 啦 ，for 那个 PV 啦，对不对？所以我那个字也给了你。Manifold action 也是有 example 讲去 code 那个 equation 了 ，OK， 那个已经是不大的问题。然后 buck converter 那个 part 也不是很大的问题。那最大的问题是怎样把这两个合起来罢了。OK 吗？So try to work out 啦 ，OK？你看除了现在我给你那些纸之外你也是尽量自己去找这种 PV emulator 用 buck converter 怎样做。你会发现到很多纸不会告诉你怎样用 Simulink 做的，你发现到吗？对不对？他们都是说我画给你，所以你基本上就是要把那个东西在 Simulink 做出来。So OK， 好像你这样子的 project 你和家孙的 project OK， 如果你们到时候在 B 可以做到一个 hardware 出来，就是小型的 hardware buck converter 嘛，因为你们两个的这个呢就会更加的增强了你们的这个 project 的 grading 啦。
OK。
这个是一个很重要的东西
Dr. Ronnie， 我的那个他也是全部给图画而已嘞。
对呀，很多人就是这样子的，他们不要给你知道他怎样做吗？然后他讲你去了解我怎样讲咯，这样我们的工作就是来啦，你不讲我就做给你看。
就是要读了过后，然后他那些 equation 就放进去 MATLAB 那种
对，很多人就是遇到这种困难。So 对咯，所以我知道学生呢每次都是因为你们也是第一次读 paper， 你们也第一次做这个。So that's why 我通常我的 FYP 我都会这样子咯，说先跟你们讲要怎样做要看哪个先，然后会给一些这些 good 你们去参考，这样子咯。
那个你给的 paper 很好他 array 小的。
对，所以不是
容易到难的
So 问题是你不可以 rely on 我每次给你 paper， 我每一个学生我一定先给他们一些 paper， 排好给你们看。 所以你们从这里你们就学习怎样去找 paper 啊。你因为到时候哦，你的 report 哦一定要有 references 哦，然后你们写 paper 的时候啊，你们 at the end of the day 也要写 paper 的嘛，对不对？So 你要有足够的 reference 哦。Dr. Lim 呢很注重这个的 ，OK， 他是
好，
他肯定
对，很注重写那个 paper，
而且那些 reference 要很重量级的，所以这个呢，我觉得 paper 我就会交给他来指导你。And then 阿邦加后，刚睡醒。
没有啊。
来 ，OK， 来。
去吃早餐。
你那个银子的东西哈，你已经 cast 到那个 shadow 了没有？
是那个树的话不美啊，因为它是2D 嘛。
我懂，不用紧啊，我们只要 approximate 罢了。我给你那两天是8月的嘛，你先看那个太阳怎样走先，因为老实讲8月的时候呢，已经接近9月了嘛。So 那个树那边的银子你也知道吗？它就不知道几点开始，它就遮到很够力嘛，对不对？它就遮到很够力。So 我给你那2个，你就大概知道哦。你看早上那个8就好了，下午是没有遮到的。下午太阳是漂亮的，它遮到都是树的一点点，或者是下雨罢了。所以1点过后的啦，都是如果你看到忽然间低，都是下雨或者很多云罢了。所以我们要 deck 的是那个早上那一点。然后那个8你有了，你大概知道哦，你是怎样遮住 ，OK，then 我们就可以simulate 它说哦，它大概是跌了多少。因为我有试过哦，在完全没有遮的情况下，我的那个 PV 的 power 是可以去到1600多了。where 那个 PV 的那个 temperature 是60度。然后你做了那8片哦，你试看你放1000 ，OK， 它差不多是1000多了，说是这个 model 就正确了。
可是看那个 data 它在1100了。
对呀，因为它不是 clear sky 吗？它最高不是你不要忘记天上面还有云的嘞。OK， 就说我们拿到那个时候可能到我们这里呢，它可能只是800罢了的，这样肯定是跌到1100、1200啊，对不对？现在你要知道的是抓那个，你能不能做simulate 1个小时啊？比如说早上的啦 ，OK， 9点、10、11到2点，看那个影子遮到那个板的什么地方，每个小时就好了，可以吗？
可以。
OK 你做一个8月几号那一天的咯，然后我再找一下我那些，因为我很多 data 都不完整 ，OK，so 这些几个比较完整的。然后你的 project 你最重要的除了找这个你的 project objective 就是要去想出一个怎样可以给我一个 access， 比如说你有了1天的 data。OK， 比如说你找8月2号那天你当做那天是漂亮的，没有云 ，OK， 你只有那几天这样遮罢了，那个 pattern 呢跟我给你的会 more or less 一样的。Then 我们加起来那个整天的那个 power， 你就可以知道它的那个是它的讲它的那个 energy 是多少了。
讲一次。
等一下，我开麦了。哇，你真的是给我感觉还没有睡醒哎。我开麦了，等一下。Clear Sky Model。
那天我去 simulate 那个决定那个 block 1好像没有挡到了。
block 1没有挡到的话就是树罢了咯。
对，一个是因为1点，那个是1点过后 drop 下来，那个是下雨
了。但是如果我没有记错它还是有挡到一点点的在早上either你 block 1那个 building 的板有没有放错位？
因为我是因为 SketchUp 那边可以直接放 image 下去的。它就直接用那个。
它完全没有 block 整个早上。
没有
OK， 8月可能没有 block OK， 你试一下9 从10月1号啊，因为9月22号已经是equinox，所以应该是在10月，我会找一个10月的data给你，你 try to 看，因为没有的话，就是靠那个数也是蛮困难一下的，靠那个数就蛮困难一下。OK ，OK， 现在我 share 我的 screen，share 我的 screen 给你。OK， 看到哦，这个我的 screen。我不知道在 share screen 的时候 run manlet 是可以的吗？第一次做，假了。哇哦，好像不能呢。OK， 可以。OK， 看到吗？OK， 到时候我会给这个你做参考。那这个是 clear sky， 就是你看啊，这个就是 OK， 这地方不对了啊。OK，
没有云的啦。
这是没有云的 ，clearness index E180%，连云都没有，所以我们的 graph 就会是这样子 ，OK，then 在这情况下呢，这个是9月21号 ，OK， 因为它不同天，比如说那个是8月几号啊
？8月2号和21号。
OK， 我8月2号啊，8月2号 ，OK， 8月2号。then 我们是3度，是蛮高的应该 ，OK， 它是这样子 ，OK，so 那天呢，我怀疑呢我们的 clearness in 你讲吗？它1,100嘛，对不对？
对。
那你看啊，没有云的话，它就接近1,300了，知道吗？所以1,100我当做它是0.8来看啊，那差不多这样子咯，0.8、0.9了，0.9又太高哦，0.85吧。这个就是那一天的 clearness index， 所以我们最高是拿到这样，就是说完全没有问题的话，没有东西挡它是这样子的 ，OK， 就是说你看到吗？我的 power 啊，那一天啊，如果是同样的情况，我的 solar panel 啦是可以拿到8.4 kilowatt hour 的这总电量 ，OK，per meter square。Of course， 因为我们发现到9点10点，因为这个板有 block 嘛，对不对？
对。
OK，so 它就会这一部分会不见了咯，就是这一部分它会低掉咯，对不对？它会少掉，说少掉多少，这个是 depend on 你要看你的影子遮到它几个，然后 based on 那个来计算。OK， 所以我的 data 是好像是蛮低的，100多罢了嘛，是在这边嘛，好像嘛类似。
很低，就是讲400都不到。
400多到这边啊，阿嘎嘎这边啊，所以它是这样子写下来的，我记得。然后最后呢就上回去了，对不对？上回去，所以它这一个部分是不见了的，它这个部分都不见，所以到时候你就 simulate 一个这个部分不见的。然后同样你又加起来这个一天的 power，OK， 加起来一天的 power， 这样你就会看到肯定少过8.4了嘛，对不对？在这个情况，so 少过8.4 ，let's say 少多少 ，so 你从这边你就可以告诉我，因为有这个shading，我一天就少了多少%。OK， 然后你就可以用2号、3号来算咯，先算1个礼拜。你损失了多少power，然后这个如果完全没有 shade， 我就可以拿到这个power。你就要找出有 shade 和没有 shade， 它的 difference 是多少。这个就是你的 objective， 明白吗？然后你要讲去，比如说是我给你的，你可以用银子，你也可以用那个 simulink， 你也可以用我这个来说 ，OK， 现在我知道我的数每天，因为1-2天它差不了多少的那个 trading， 对不对？2-3天你就知道哦，哇，从3-4点就开始有 shade， 因为它 shade 多少在这个 part， 你一定要 base on 你那个 model 告诉你才懂的嘛。它的 maximum 换了多少， 所以我们就可以再用这个来做一个 reference。这个会是说完全没有 shade 的情况下 ，OK multiply by 你的那个 sizes，OK of the， 因为这个 kilowatt hour per meter square 是你的太阳的 irradiance 啊，不是你的 panel 哈 ，OK， 所以你还要打一些 factor 的，所以你的 FYP model 你做了，那个8片呢你也做了，现在跌下来的就你已经做了，所以你好像你给我看吗？可以 run 了嘛，对不对？temperature set 在60度啊，因为你在这种上晒的时候是60度，我量过了。set 去60度 ，OK， 然后我们就要知道那个因子所在罢了。现在也是很麻烦，现在我在想怎样应该 after MCO 你也是可以回去那边看看一下啦，到时候整个情况。但是你这段时间是最漂亮的嘛，因为5月到7月基本上是最少雪的。所以我现在很积极的写作那个 update 做那个 program 去可以录到比较好的那些 data 给你。然后9月到12月就最多雪了，那时是你的 internship。然后你回来的时候，如果那些 data 有，你就更漂亮了。你现在最重要的是，你要 OK， 你要写下来，在一张白纸或者是什么 type 下来也好，你要讲去不是算是 assess 有 shade 和没有 shade 的分别，那个 size， 明白吗？你要找出一个 method 出来这些东西都是 tools 罢了的，好像 sketch 我给你那个，还有这个都是 tools。你现在有了 screwdriver， 你有 hammer 有些，然后你要讲应用它们去做一个东西出来，就是 assess 它。你明白吗？
就是要算它的 loss 是多少
对，怎样算它 loss 比较 effective， 是很多方法的。你也可以用，我每天这样算也是可以的吧，它很不 effective 咯。所以你从你这些 tools 里面，你可以看到有什么 information 可以用到的，可以拿来给你去做。你看，你一定要知道完全没有 shade 的时候是怎样嘛，对不对？所以你就需要用到这个了。
可是这样如果用每个小时然后convert去1天可以吗？
可以啊，要用小时考虑一点是可以的。通常一开始先用小时先的，然后过后你才用分钟，因为你小时比较容易算嘛 ，hour 嘛，我这个是分钟我没有记错。不用紧，东西要快要简单 ，basic 一定是 start with 小时先的，这样你就比较容易了嘛，那个时间，then 还有呢，就是到时候你看我这个还有一个 function 的，我可以 import data， 到时候我们可以，等一下OK， 到时候我就可以 let's say 我可以 import 一个 data 进去，就是我给你那个812号啦，你可以用它来 model 了果然 share screen 真的是很慢呢。我好像等一下关掉一下先。
这什么
没有，我忘记了，我们还在 record。